Welcome back to Three Inquisitive Kids. My name is Karen, and from the last video, we learned all about combining like terms in linear equations. In this video, we will be continuing our lesson on simplifying linear equations through learning all about removing brackets. Learning goals. Master the concept of removing brackets, able to accurately solve linear equations using removing brackets. Here's our introduction. So as you can see, this boy walks up to this lady and he says, I would like 1 fruit milk and 4 colas. And from this little guy, we know 1 cola is $0.5 more expensive than 1 fruit milk. And then this lady says, I'll give you a change of $3. And as you can see here, this boy is handing her a $20 bill. So how much does 1 fruit milk cost? If he paid for 1 fruit milk and 4 colas, and he received with a $20 bill, received a change of $3, and we know that 1 cola is $0.5 more expensive than 1 fruit milk. This is where removing brackets come in. So you can pause the video and think about what equation would accurately represent this problem. But then afterwards, you'll see that there's a problem in the solution to solve that equation. There are parentheses or brackets. So how would you solve that? If you set 1 fruit milk to cost X dollars, the equation that can be listed is 4 times the sum of x and 0.5 plus x is equal to 20 minus 3. How can you solve this equation with brackets? Remove brackets, and you have 4x plus 2 plus x is equal to 17. So here what it did was you went from this to this. You multiplied this 4 using the distributive property, and you multiplied it into each of the terms of in this parentheses. So this is using the distributive property of multiplication. So you transpose terms, combine like terms, divide both sides by 5, and then your solution is x is equal to 3. So therefore, 1 fruit milk costs $3. Through the process of solving the equation above, can you summarize the general steps to solve linear equations with brackets? Well, first, you remove the brackets. Then you transpose terms, combine like terms, and then finally isolate the variable. Let's do some practice. Solve -2 times the difference of x and 1 equals to 4. First, we remove the brackets, so we use the distributive property to multiply -2 into the parentheses, giving us -2x plus 2 is equal to 4. And then we use the knowledge we learned from the last video to transpose terms and then simplify, which we get x is equal to -1. If you didn't watch our last lesson on combining like terms, I highly recommend you do so, and you can do that by going to the description down below and then clicking the link that I will be including in there. Can you think of a different solution? Well, first, let's look at this parentheses x minus 1 as a whole. Method 2. You can first divide both sides by -2 to get x minus 1 is equal to -2. After transposing terms, you have x is equal to -2 plus 1, or x is equal to -1. What's different here is that instead of first distributing the -2 into the parentheses, this person decided to just divide both sides by -2 to get rid of that factor all at once. And then you have x is equal to blank, and then it's easier to solve. So either of these two methods are fine. Removing brackets, there's different possible ways to do it. Specific problems might have a different trick to them. The main method that we are learning today is that first method, using the distributive property. But this method too is also very clever, and if you sometimes come up with a way to do things differently, that is highly encouraged. Discuss. Compare the above two solutions and then talk about their differences. You can think of, since I can't exactly talk with you through this video, you can just use something and then think by yourself. Compare these two solutions like we just did, and find their differences and which ones would work better and how their different ways of thinking are different. Solve 2 times x plus 3 minus 5 times 1 minus x is equal to 3 times x minus 1. Well, here, the things in the parentheses aren't exactly the same, meaning we can't just divide both sides by a number. So what we can do is first use a distributive property to factor 2, 5, and 3 into their parentheses. So we have 2x plus 6 minus 5 plus 5x is equal to 3x minus 3. Transpose terms, combine like terms, yada yada yada, and then we have x is equal to negative 1. What should be paid attention to when solving equations by removing brackets? If you pause the video to try to solve this on your own, and then you went back and then you compared your solution with this solution, did you get the right answer? If you did, great job. But if you didn't, where did it go wrong, and what should you pay attention to next time? So when you're removing brackets, if you're simplifying a parentheses and it's positive, on the outside it's positive, the sign after distribution, so this is very important, let me add this in, after distribution does not change. But if this is negative, after distribution, the sign in these parentheses do change, because you're actually multiplying a negative something to, so essentially multiplying negative 1 to each of those terms in that parentheses, meaning that it has to switch its sign. Written mathematically, a plus the sum of b and c, it would be equal to a plus b plus c. But if it was a minus b plus c, it would be a minus b minus c. So plus b turns to minus b, plus c is equal to, turns into negative c. Let's do another problem. If the solution to 3 times 2x minus 1 is equal to 2 minus 3x, and 6 minus 2k is equal to 2 times the sum of x and 3, if those two equations have the same solutions, what is the value of k? The value of k would be, pause the video to find this on your own. Okay, so since each of these have the same solution, meaning that x is the same in each of these equations, we can first solve the value of x from this first equation. So after solving the solution to 3 times 2x minus 1 is equal to 2 minus 3x, and then you can substitute it into this second equation. Therefore, you can find the value of k. The answer in the end would be b, negative 5/9. If function m minus 6x is equal to m minus 4 has a solution of x is equal to 2, then m is equal to, well, first we substitute x as 2 into this equation. So 2m minus 12 is equal to m minus 4. So we get 8. When x is equal to 2, algebraic expressions m minus 2x and m plus x have the same value. Find the value of m. Well, again, you can substitute 2 in here, and then since they have the same value, you can write an equation between m minus 2x, m minus 2 times x is equal to m plus x. So therefore, solved, m is equal to x. M is equal to 6. Apply the removal of brackets to solve equations. It takes 2 hours for a ship to travel downstream from pier A to pier B. it takes 2.5 hours to travel upstream from pier B back to pier A. So the keyword here would be downstream and upstream. Remember, these two are different because there is a different direction that the water is moving in. So if you were going upstream, you would be going slower than going downstream, hence the difference in time, since the speed doesn't change. Given that the speed of the current is 3 kilometers per hour, what is the speed of the boat in still water? So meaning, what is the speed of the boat when there is no current? Let's do this problem together. Fill in the blanks. Here's the equivalent relationship. Since the total distance on both trips was the same, then the downstream speed times the downstream time is equal to the upstream speed times the upstream time. So here's our solution. We can assume that the average speed of the boat in still water, so what we're trying to find, is x kilometers per hour. Therefore, the speed of the ship in going downstream would be shown as x plus 3 kilometers per hour, and the speed of the ship going upstream is x minus 3 kilometers per hour. The equation that can be listed as 2 times x plus 3 is equal to 2.5 times x minus 3. We can remove brackets, transpose, and combine like terms, and then we have x is equal to 27. Our answer is the speed of the boat in still water is 27 kilometers per hour. So this is something we emphasized in the last video. So when you're writing your solutions, really make sure you're writing it in neat steps like this. You know what you're doing, you know how you got that result, and remember to have this top step where you're listing out the variables, and this last step, which is a colon. Here's my answer. The speed of the boat is blank. Now it's just really a lot of practice because you got to really get into that routine and really be able to do it quick and accurately. A plane flies between two cities on a wind speed of 24 kilometers per hour. It takes 2 hours and 50 minutes to fly downwind and 3 hours to fly upwind. Find the distance between the two cities. This is just like the last problem, except instead of taking place on the water, it's taking place in the air. So you can think of the wind as the water. When in water, they both have speeds. So upwind and downwind, upstream and downstream, are kind of the same concept here. I want you to pause the video and use sort of the same basis and analysis from the last problem to solve this problem as well. Okay, what answer did you get? Here is something that your solution might have looked like. Here's our solution. Let the plane speed be x kilometers per hour. Therefore, the downwind speed would be x plus 24 kilometers per hour, and the upwind speed is x minus 24 kilometers per hour. The equation 17 over 6 times x plus 24 is equal to 3 times the difference between x and 24. Solved. So here we don't have enough space, but if this was you would really have to write all those solutions out. So solved, x is equal to 840. The distance between the two cities is 2,448 kilometers. Class summary. Removing brackets and linear equations. We learned about the things that you have to pay attention to when removing brackets. So I guess precautions. Make sure you're paying attention to changing the sign after, so especially if that parentheses has a negative sign in front of it, and then you're just using the distributive property of multiplication to factor in that factor in front of the parentheses. I want you to make sure that you are changing the signs of the terms if it is a negative factor. And we also learned to solve linear equations with brackets, especially in word problems. So these are the 4 general steps. First, to remove the bracket, transpose terms, combine like terms, and then finally isolate the variable. So really the difference between this lesson's problems and last lesson's problems was that we added one more step, which was to remove brackets. The two skills we learned today, to review: master the concept of removing brackets, able to accurately solve linear equations using the removal of brackets. Thank you so much for watching 3 Inquisitive Kids, and hit the subscribe button and the notification bell to stay notified for the upcoming videos.